Hi! In this video series, we are going to make a programming language interpreter from scratch. Before we start, I'd like to clarify everyone that this is not a series for how to copy and paste your own interpreter. This series requires a fairly good level of programming knowledge. In the first few tutorials, we will talk about a lot of theory, then we will move on to the practical stuff. I'm gonna be coding in Java, as it is fairly simple, understandable, and easily translatable into C++ and other languages. The source of the interpreter that we will make will be available on GitHub for everyone. First, we have to talk about what an interpreter really is. An interpreter is a computer program that directly executes the instructions written in a programming language without being needed to compile the source into machine language first. This has a lot of advantages, but also some drawbacks. An interpreter usually can be made platform independent, dynamic types are easy to implement, and the written programs are smaller in size, because there's no need to compile the program. But their execution is usually slower, and you cannot prevent others from looking into your code, which is not even a huge disadvantage if you're a fan of open source. So why are we making an interpreter and not a compiler? Actually, they're almost the same, they only differ in the last step, which is execution versus creating the binary. I don't want to mess around with binaries, so for simplicity we will stick with the interpreter. Well-known usually interpreted languages are Python, Ruby, JavaScript, and others. Java, for example, is both compiled and interpreted. First, the source is compiled into Java bytecode, and then the JVM interprets that. Now the next thing. What's the process of execution? It consists of three basic steps. First, the given source file goes through a lexical analyzer, which outputs a list of tokens. Second, a parser parses the token list and creates some kind of representation of the program in memory. This can be usually an abstract syntax tree, or AST for short, or a higher level bytecode. Lastly, the interpreter actually executes the program. Here the compiler would create the binary file instead. This is the only step that the compiler and the interpreter differ in. Note that there can be extra steps like simplification, and some interpreters do lexical analysis while parsing, so they basically merge the first two steps. I've just mentioned the most essential and common ones. There will be a more detailed explanation before every step, so don't worry if you don't have any idea of what these steps are. Now you have a better understanding of what an interpreter is. But for what language are we gonna make our interpreter? We could create one for an existing language, like BASIC, but I've decided to design my own simple language for these tutorials. Let me introduce you a simple language that I designed called Scilang. It will be perfect for a simple interpreter project. Of course, you can come up with your own language. Here's the syntax of Scilang. In Scilang, variable definition is just an assignment. If the variable doesn't already exist, it will be defined just like in Python. Single line comments, if and while statements are supported along with function definitions, and a Python 2-like print statement. Every code block starts with a colon and ends with the keyword end. You can use curly brackets instead if you prefer a more C-like syntax. This won't be the complete language. We will add for statements, arrays, and a lot more later. This is just the minimum that we will need for now to start. In the next tutorial, we will discuss what a context-free grammar is, and we will write one for Scilang. And that's it for this tutorial. Thanks for watching.